A continent's vibrant heart turned to dust. This is the story of the day the rainforest became a desert, a real-world cataclysm that reshaped our planet. We are about to reconstruct this dramatic transformation, unlocking a mystery buried in ancient soil and fossilized pollen. By the end of this journey, you will understand the powerful forces that can flip an entire ecosystem from paradise to wasteland. How could a landscape so full of life simply vanish? What hidden clues finally revealed the truth behind this ancient collapse? How does a world cross a point of no return? The answers hold urgent lessons for our own time of environmental change. What do you believe it takes for an entire world to transform? The Sahara was not always a sea of sand. For millennia, this vast expanse was a sprawling green savannah, a world of shimmering lakes and winding rivers. Herds of elephants and hippos wallowed in its waters, while early human communities thrived along its fertile shores. This was the African humid period, a lush chapter in Earth's history that lasted for thousands of years. Our story focuses on the dramatic end of that era. Roughly between 6,000 and 5,000 years ago, this vibrant world began to wither. The life-giving rains faltered, the vegetation retreated, and the Great Lakes shriveled into salt pans. This was not a local dry spell. The transformation of the Sahara was a planetary event, a fundamental shift in climate that rippled across the globe. To grasp the sheer force of that collapse, we must first comprehend what was lost. How does a landscape supporting such immense life simply give up? The answer lies buried beneath the dunes, waiting to be uncovered. To read this story, scientists had to become detectives of deep time. Their toolkit is a form of high-tech archaeology, designed to decode the faint signals left in the earth. One of the most powerful clues comes from the bottom of the ocean. Far off the coast of West Africa, researchers drill down into the seabed, pulling up long cylinders of mud known as sediment cores. These cores are like a library of the past, with each layer of sediment a page in a history book. The deeper they go, the further back in time they travel. Within these muddy layers, they find something surprising: tiny grains of dust. This is not ordinary dust. It is Saharan dust blown across the ocean by ancient winds. By measuring the amount of this dust in each layer, scientists can create a timeline of aridity. When the Sahara was green, the dust was scarce, but as the desert took hold, the winds carried immense plumes of dust out to sea, leaving a clear signal of the catastrophe in the ocean floor. Another vital clue is hidden in the remains of ancient lakes. In places that are now completely dry, scientists find layers of sediment that were once lake bottoms. Preserved within that mud are fossilized pollen grains, so small they are invisible to the naked eye. Each type of plant has a uniquely shaped pollen grain. By identifying these grains, researchers can reconstruct the entire plant community that lived there thousands of years ago. They can see the exact moment when the pollen from lush grasses and savanna trees disappears, replaced by the pollen of hardy, desert-adapted shrubs. It is a silent witness to the last breath of a green world. Perhaps the most elegant record of all comes from deep within caves. Stalagmites, those stone pillars that rise from cave floors, grow incredibly slowly, layer by layer, over millennia. They are made of minerals deposited by dripping water. The chemical composition of each layer, the ratio of different types of oxygen atoms, is a direct proxy for rainfall at the time it formed. More of the heavier oxygen isotope means more rainfall. Less of it means drought. By analyzing these layers with lasers, scientists can read a year-by-year diary of the Sahara's rains, watching the precise rhythm of the monsoons weaken and eventually fail. Finally, technology peers through the sand itself. Ground-penetrating radar and satellite imagery can map the ghosts of rivers and lakes now buried under vast dunes. These hidden waterways, these skeletons of lost watersheds, show just how extensive the water network once was. Together, these methods form an unassailable case. The dust, the pollen, the cave minerals, and the buried rivers all tell the same story, but knowing that the climate changed is only the first piece of the puzzle. The real mystery is why. What colossal force could so decisively tilt an entire continent toward desert? Our first tangible piece of evidence lies at the bottom of the Atlantic Ocean. Far from the sun-baked dunes of today, deep sea cores drilled from the seabed reveal a startling change. In layers of sediment dating back around 5,500 years, scientists found a dramatic spike in microscopic dust. This is not just any dust. Its mineral fingerprint is uniquely Saharan, a telltale sign of what was happening on the continent. This sudden, immense plume of dust tells a clear story. The land was being stripped bare. The vibrant green carpet of grasses and trees that once held the soil in place was vanishing. Without that living anchor, the earth was left vulnerable, exposed to the wind. Vast quantities of fine sediment were lifted into the sky, creating an atmospheric river of dust that flowed all the way across the ocean. The sheer volume is almost impossible to comprehend. So much dust was blown westward that it continues to fertilize the Amazon rainforest today, carrying essential nutrients across an entire ocean. This same dust influences weather patterns, affecting the formation of hurricanes in the Atlantic. That layer of dust in the deep sea mud is more than just sediment. It is a continental-scale signal of collapse, a direct recording of the moment the land began to die. The desert found its voice, and it spoke in a whisper of minerals carried on the wind for thousands of miles. While the ocean floor recorded a continent's dust, the land itself held an even more dramatic testament to the loss. Across the Sahara, the ghosts of vast megalakes tell a story of a world drowning in water before it was consumed by sand. The most staggering example is ancient Lake Chad. Today, it is a shallow remnant of its former self, but 5,000 years ago, it was an inland sea, a body of water larger than the entire Caspian Sea is now. Its fossilized shorelines, now stranded in the middle of absolute desert, trace the contours of a lost world. We can stand on these ancient beaches today, 100 miles from the nearest significant water, and find the same kind of wave-smoothed stones you would pick up on a modern lakeshore. It is a deeply disorienting experience, a physical connection to a climate that has completely vanished, but the evidence goes far deeper than shorelines. In the heart of the most hyper-arid deserts, places where no rain falls for years, researchers unearth layers of sediment filled with the delicate, glassy skeletons of diatoms. These are microscopic algae that thrive only in fresh, sunlit water. Their silent, fossilized presence in the sand is definitive proof. This barren, scorching landscape was once the bottom of a clear, freshwater lake, teeming with invisible life. By dating the sediments that entomb these diatoms and the fossilized shells of freshwater snails, scientists can track the life and death of these megalakes with astonishing precision. The timeline is unequivocal. The lakes did not slowly shrink over hundreds of thousands of years. They underwent a rapid, catastrophic desiccation, their shorelines retreating dramatically within centuries. This collapse aligns perfectly with the dust record from the Atlantic, creating a convergent, undeniable timeline of disaster. The story these dying lakes tell is one of a water cycle in collapse. The life-giving monsoon rains that had fed them for millennia were failing. The delicate balance between rainfall and evaporation was shattered, with the relentless sun and wind overwhelming any replenishment. The great inland seas shriveled, their waters evaporating to leave behind vast, blindingly white salt pans. The fate of Lake Chad and its vanished siblings is more than just a curiosity. It is a stark hydrological record, a giant rain gauge from the past showing the precise moment the skies over an entire continent began to run dry. But what force could reach into the sky and command the rains to stop? The answer does not lie on the land, but in the slow, rhythmic dance of the planet itself. Buried in the mud of long-vanished lakes is a silent, microscopic witness to the collapse. While the dust told of a land laid bare and the ghost lakes spoke of failing waters, the pollen record reveals the intimate, biological death of the world. Scientists drill into these ancient lakebeds, now sun-baked and cracked, and pull up cores of sediment. Within these muddy layers, they find an incredible archive, tiny, indestructible pollen grains from plants that died thousands of years ago. Each type of plant produces a pollen grain with a unique shape, like a microscopic fingerprint. By counting and identifying these grains in each layer, researchers can reconstruct the entire plant community that once thrived there. It is like reading a detailed diary of the landscape, written in a language only visible under a microscope. The story it tells is one of dramatic and rapid upheaval. In layers dating to the Green Sahara, the pollen is a vibrant mix. There are grains from dense, waving grasses that supported vast herds of animals. There is pollen from acacia trees offering shade and sustenance. There is evidence of shrubs and herbs, all coexisting in a rich, tangled web of life. This was a thriving savannah, a complex and resilient ecosystem. Then, in a geological instant, the record changes. The diverse pollen signature shatters, the grass pollen plummets, the tree pollen vanishes. In their place, a new, hardy cast of characters takes over. The pollen record becomes dominated by desert-adapted plants, species like chemopods and amaranths, which can survive on little water and in poor soil. This was not a slow, graceful retreat of the forest. This was a swift, systematic unraveling. The complex web of life, WAS Chinese letter, stripped down to its most basic, desperate components. The ecosystem did not migrate, it collapsed on the spot. This botanical shift happened over just a few centuries, a mere blink of an eye for our planet. Think of a thriving, noisy city. First, the specialized shops close, then the restaurants, then the schools. The population dwindles. Soon, only the most essential, rugged services remain, struggling to survive. The pollen record shows us this exact process, but for an entire continent. It reveals the order of the collapse, species by species, as the life-giving rains faded away. This microscopic evidence confirms the climate was not the only thing changing. The very fabric of the living world was being torn apart. But to understand why the rains failed, we must look beyond the Earth itself, to the slow, rhythmic wobble that guides our planet's climate. The most powerful force that reshaped the Sahara was not on Earth, but in the slow, celestial mechanics of our planet's motion. The long-term rhythms of Earth's climate are conducted by predictable changes in its orbit and axial tilt, a set of cycles named for the scientist who first calculated their profound influence. Think of these Milankovitch cycles as a great cosmic clock ticking with immense slowness. Around 8,000 years ago, the hands of this clock were in a position that brought profound life to North Africa. A slight shift in the planet's tilt meant the northern hemisphere received more intense summer sunlight. This extra solar energy acted like a furnace, heating the continent and pulling the life-giving monsoon rains deep inland. It was this astronomical gift that supercharged the African monsoon, creating the Green Sahara and its world of lakes and savannas. But a clock's hands never stop moving. Over the following millennia, that same orbital configuration slowly drifted. The tilt of the Earth subtly changed, and with it, the intensity of the northern hemisphere's summer sun began to wane. The furnace was turning down degree by imperceptible degree. This gradual reduction in summer insolation had a direct and devastating consequence. It weakened the engine of the monsoon. The system that had pumped moisture from the oceans into the heart of the continent for thousands of years was losing its power. The rains began to falter, their reach growing shorter, their duration less reliable. This celestial driver provided the initial, inexorable push toward a drier state. It is the ultimate pacemaker, setting the slow, background rhythm against which the more rapid and visible drama of the Sahara's collapse was destined to play out. Yet a crucial mystery remains. The orbital shift was a gradual process, unfolding over thousands of years. But the evidence from the dust, the lakes, and the pollen points to a transformation that, while not instantaneous, was remarkably swift in geological terms. It happened over centuries, not millennia. If the pacemaker provided a slow, steady push, what was the final shove that sent the ecosystem tumbling over the edge so decisively? The answer lies not in the slow dance of the planets, but in the Earth's own dynamic and often fragile systems. The planet's slow wobble may have set the stage, but the final act of the Sahara's transformation was directed by a powerful and self-reinforcing feedback loop. This is the story of how the dying landscape itself became the engine of its own destruction, a process centered on a simple but profound concept known as the Albedo Effect. Albedo is just a scientific term for how much sunlight a surface reflects. Think of wearing a black shirt on a sunny day versus a white one. The dark fabric absorbs the sun's energy, making you feel hot. The light-colored shirt reflects that energy, keeping you cooler. The Earth's surface works in exactly the same way. During the Green Sahara, the continent was wearing a dark shirt. Lush green vegetation and dark, rich soils absorbed vast amounts of solar heat. This warmed the land surface, causing the air above it to rise. That rising air created a low-pressure system that acted like a giant vacuum, pulling in moist, rain-filled winds from the Atlantic Ocean. This was the very engine of the monsoon, a cycle sustained by the land's own darkness. But as the orbital shift gradually reduced the rains, the first plants began to struggle. Grasses died back, leaving patches of bare, light-colored soil exposed to the sun. This was the critical tipping point. Those bright patches started reflecting more solar energy back into space, like switching from a black shirt to a white one. This cooled the land surface, weakening the thermal low-pressure system that pulled the monsoon inland. The rains faltered a little more. With less rain, more vegetation died, exposing even more reflective ground. The brightening landscape further cooled the land, further crippling the monsoon, leading to even greater drought. This created a vicious, self-amplifying cycle. Each step fed the next, accelerating the collapse. The change was no longer just a slow response to a celestial rhythm. It was a runaway train with the albedo effect pouring fuel on the fire. The Green Sahara did not just fade away. It was actively pushed into a new, permanent state of aridity by its own changing color. This powerful feedback loop helps explain the startling speed of the transformation seen in the geological record. But another invisible player was also entering the stage, one that would choke the life out of the remaining plants and seal the continent's fate. While the albedo effect was changing the continent's color, a quieter, more intimate feedback loop was beginning to choke the life from the air itself. This second mechanism centered on the plants and their vital relationship with the very water they help to create. In a healthy savanna, vegetation is far more than a passive occupant. It is an active participant in the water cycle. Every blade of grass, every acacia tree acts as a tiny, living pump. Through their leaves, they release vast quantities of water vapor into the atmosphere in a process called transpiration. This constant exhalation of moisture humidifies the air, helping to seed the clouds that will bring the next rain. The plants were not just waiting for the weather, they were helping to make it. Their extensive root systems also worked like a sponge, holding precious rainfall in the soil and preventing it from simply evaporating or running off. This created a self-sustaining loop of life and water. The rain fed the plants, and the plants, in turn, helped to summon more rain. But this beautiful symbiosis contained a terrible vulnerability. As the orbital shift slowly reduced rainfall, the first plants began to suffer from drought stress. Grasses withered and trees died back. With every patch of vegetation that was lost, a tiny water pump was shut off forever. Less transpiration meant less moisture entering the atmosphere. The air grew drier and the clouds became scarcer. This led to even less rainfall, which then killed off more plants, shutting down even more pumps. The system was caught in a vicious, self-reinforcing spiral. The loss of life was directly making the environment more inhospitable to life. The ecosystem, which had been a bastion of resilience for millennia, had become an unwitting accomplice in its own destruction. It was a slow-motion suffocation where the continent's green lungs were systematically dismantled, ensuring they could never draw breath again. This biotic feedback, working in concert with the Albedo Effect, accelerated the drying trend from a gradual drift into a rapid, unstoppable collapse. The stage was now set for the final, silent actor to step in and lock in the new, arid reality for good. Far out at sea, another powerful actor was quietly turning a dial, one that controlled the very rain that fed the continent. The ultimate source of the Sahara's lifeblood was the tropical Atlantic Ocean. Its warm waters act as a vast engine, evaporating moisture into the atmosphere that is then carried inland by prevailing winds. But the delivery of this moisture is not random. It is directed by a precise and delicate balance of sea surface temperatures. For the Green Sahara to exist, a specific thermal pattern was essential. Cooler waters to the north and a pool of warm water to the south worked in concert to steer the African monsoon rain belt deep into the heart of the continent, like a conveyor belt of clouds. Paleoclimatological data, however, reveals a dramatic shift in this oceanic engine right around the time of the collapse. Evidence from marine sediment cores points to a significant cooling of the North Atlantic. This chill was likely a distant echo of the Great Ice Age, a final pulse of cold, fresh meltwater pouring into the ocean from the disintegrating northern ice sheets. This single change had a catastrophic domino effect. The cooler northern waters disrupted the thermal gradient that guided the monsoon. It was as if someone had moved the tracks. The entire rain belt was shoved southward, hundreds of miles from its former path. For the Sahara, this was a death sentence. The conveyor belt of clouds was abruptly rerouted. The skies over the savannas and megalakes simply emptied. This highlights a profound truth about our planet's climate. A transformation in one part of the world, in this case the melting polar ice, can send a shockwave across the globe. The Atlantic Ocean, in effect, became a remote control for the Sahara's climate, and from thousands of miles away, a switch was flipped to the off position. With a rain tap severed, the feedback loops of albedo and vegetation took over, accelerating the collapse into an unstoppable cascade. But how did the people and animals who called this paradise home witness its final, dramatic act? Amidst these colossal forces of orbital shifts and climate feedbacks, a new and controversial actor enters the story. Could the hands of our own ancestors have helped to push the green world over the edge? This is the Herder hypothesis, a theory that introduces a deeply human element to the Sahara's collapse. As the climate began to dry, nomadic pastoralists arrived on the savannah with their herds of goats and cattle. These animals were not inherently destructive, but their relationship with the land may have become a precarious one at a critical moment. The principle is one we still see today. Overgrazing removes the protective cover of grasses. Without those roots to hold it together, the fragile topsoil is exposed. It can be blown away by the wind or washed away by the occasional, intense rainstorm. The land becomes compacted like a hardened pavement, losing its ability to absorb and store what little water does fall. Think of a well-trodden path across a field where nothing grows. Now imagine that path widening until it becomes a vast, barren patch. This process would have directly amplified the existing feedback loops. By stripping away vegetation, herders could have unintentionally accelerated the albedo effect, making the ground brighter and the monsoon weaker. By compacting the soil, they would have further crippled the land's ability to support the remaining plants, deepening the drought. It is crucial to understand the scale. These were not industrial farmers, but small, mobile communities. They did not create the desert. The primary drivers were, without question, the planetary forces we have already explored. Yet, at the tipping point, their presence may have been the final, decisive weight. When an ecosystem is balanced on a knife edge, even a small, consistent pressure can be enough to send it tumbling into a new and permanent state. This idea forces us to reconsider the ancient relationship between humanity and nature. It suggests that our footprint, however light, may have been part of a global catastrophe thousands of years ago. It adds a layer of profound complexity to the mystery, blurring the line between a natural disaster and one that we, in some small part, helped to right. The final question is one of speed. With orbital forces, ocean currents, and feedback loops all aligned against it, how quickly did the green world vanish? The evidence points not to a slow fade, but to a breathtakingly rapid unraveling. High-resolution data from deep-sea mud, ancient lakebeds, and cave minerals all converge on the same startling timeline. The transition from a verdant savanna to a barren desert did not play out over thousands of years. It was a collapse compressed into a span of just a few centuries, a geological heartbeat. This velocity points to a single, terrifying concept, a climate tipping point. The Sahara did not gradually evolve into a desert. It flipped. For millennia, the ecosystem had absorbed the slow, steady pressure of the changing orbit. It was like adding weight to a scale, one tiny grain at a time. The system held its balance, resilient and green, but there was a limit, a specific threshold of aridity that, once crossed, triggered an irreversible cascade. The feedback loops of albedo and vegetation, which had once sustained life, suddenly became a trap. The moment the landscape became just a little too bright and a little too barren, these loops kicked into overdrive, locking the entire region into a new, permanent state. This is the nature of non-linear change. A slow, almost imperceptible pressure from a wobbling planet did not produce a slow, graceful decline. It resulted in a violent and decisive regime shift. The system did not adjust, it shattered. One day, the last savanna trees stood against a drying wind. Within a few human generations, they were gone, their roots buried under an advancing tide of sand. The desert did not arrive with a whimper. It arrived with a bang, a dramatic and final transformation that echoes an urgent warning for our own time. The silent walls of the Cave of the Bats hold a gallery of ghosts. Deep within this shelter in the heart of modern Niger, vibrant paintings adorn the rock, a stark and beautiful contradiction to the barren plains outside. Here, etched in ochre and charcoal, are giraffes with impossibly long necks, hippos wallowing in rivers, and vast herds of cattle being tended by human figures. This is not an artist's fantasy. It is a direct snapshot, a family photo album from a world that no longer exists, created by the people who thrived during the Sahara's green prime. The art is a testament to a life of abundance, a daily reality where water was plentiful and the savannah teemed with creatures we now associate with lands far to the south. Then, abruptly, the paintings stop. The creative burst that chronicled a thriving ecosystem falls silent. The archaeological record reveals a corresponding void, a layer of sterile sediment with no tools, no hearths, no signs of human life. This hiatus in occupation spans centuries, a stark emptiness that coincides perfectly with the climatological data of the collapse. The cave was abandoned because the world outside could no longer support its inhabitants. When people finally returned to the shelter, the world had been remade. Their culture was different, their tools were adapted for a new, harsher reality. The art they left behind was no longer of crocodiles and giraffes, but of the desert-adapted animals that remained. This single location, from its vibrant beginning to its silent middle and its starkly different end, provides a human face to the graphs of dust and the charts of rainfall. It transforms an abstract climate tipping point into a story of real people, a culture displaced, forced to migrate, and compelled to reinvent their entire way of life. The cave story is a poignant reminder that these geological events were not just shifts in data, but catastrophes that echoed through human generations, severing connections to ancestral lands and rewriting the map of human civilization. The silence of the cave speaks of a world left behind, but outside, a new world was being born from the dust. The desert did not erase life, it ruthlessly selected it. This was evolution's great filter, where the price of survival was a radical transformation. The vibrant savannah, with its tapestry of thousands of species, was winnowed down to a handful of the toughest, most resourceful forms of life. The creatures that had defined the Green Age faced a stark choice: adapt, migrate, or perish. The great elephants and hippos retreated south, their old migratory routes now severed by an ocean of sand. For those that stayed, the desert demanded nothing less than a biological reinvention. The fennec fox, with its enormous ears, became a master of thermoregulation, radiating heat and listening for the faintest scratch of prey beneath the dunes. The addax antelope evolved to travel vast distances without water, drawing every drop of moisture it needed from the sparse, dry grasses it consumed. Life did not end, it condensed into a series of brilliant, specialized survival strategies. This same principle of harsh selection reshaped the plant kingdom. The vast, waving grasslands were gone, replaced by a scattered community of botanical survivors. Hardy desert shrubs like saltbush developed tiny, waxy leaves to minimize water loss. Acacia trees, once part of a dense woodland, became lonely sentinels of the plains, their deep taproots probing incredible depths for hidden aquifers, and their thorns defending precious leaves from hungry animals. These plants did not merely endure the new climate, they mastered its rhythms. Many developed seeds that could lie dormant for years, waiting for the rare, perfect downpour to trigger a frantic, fleeting bloom of life. The ecosystem was simplified, stripped of its former complexity, but it was not lifeless. It was a world honed to a sharp, efficient edge. Humanity, too, was filtered by the sands. The communities that remained did not simply cling to existence. They developed a profound, intimate knowledge of the new desert. They became masters of reading a landscape that appeared barren to the untrained eye. They learned to find water by observing the flight patterns of certain birds toward hidden seeps, or by digging in specific dry riverbeds where water lay trapped just below the surface. Their entire social structure shifted to one of nimble mobility. Nomadic pastoralism became the dominant way of life, a constant, strategic movement of herds across vast territories to track the unpredictable patches of rainfall and grazing. Their material culture became one of minimalism and portability, tents instead of villages, knowledge instead of possessions. They learned to live with the desert not as a conqueror, but as a partner in a delicate, demanding dance. Beyond its biological and cultural revolutions, the new Sahara erected a formidable wall across the African continent. What was once an open corridor of savannah became an impassable barrier for most species, including humans. This had a profound and lasting effect. Populations of plants, animals, and people to the north and south of the desert were now genetically isolated, evolving along separate paths for thousands of years. This great divide would go on to influence the spread of technologies, the rise of empires, and the very genetic makeup of the continent. The desert shaped history by dictating where people could go and who they could meet. Trade routes were forced to its fringes, creating oases of cultural exchange along its edges, while its vast, empty interior remained a world apart. The day the rainforest became a desert was not an end, but a violent and creative new beginning. It forged a unique realm of life, culture, and history, proving that even in the most dramatic collapse, the Earth holds the seeds of a new world. This new desert did not just rewrite the map of Africa. It began to speak to the entire planet, its voice carried on the wind. The very same dust that signaled the continent's collapse in the deep sea cores became a life-giving force thousands of miles away. Every year, immense plumes of fine Saharan dust are lifted high into the atmosphere, embarking on a transatlantic journey. This dust is far from inert. It is rich in minerals, most critically iron and phosphorus, elements that are often in short supply in the open ocean. When this mineral wealth rains down on the sunlit surface of the Atlantic, it acts like a potent fertilizer, triggering vast blooms of microscopic phytoplankton. These tiny plant-like organisms are the foundation of the marine food web. In a very real sense, the productivity of the entire tropical Atlantic, the fish, the whales, all of it, is partly fueled by the dust of a distant, dead world. But the journey does not end there. A portion of this dust travels even farther, crossing the entire ocean to settle over the Amazon rainforest. The Amazon sits on highly weathered, ancient soils that have been leached of their nutrients by millions of years of torrential rain. The constant, gentle rain of Saharan dust replenishes this loss, providing essential phosphorus that helps sustain the incredible lushness of the jungle. The world's largest desert is paradoxically a primary benefactor for the world's largest rainforest. This transcontinental dust flow is one of the most dramatic examples of Earth's interconnected systems, a biogeochemical bridge between two seemingly separate worlds. Yet the desert's influence extends beyond this slow, fertilizing rain. The very presence of a massive, hot, and bright surface where a cool, dark savannah once stood fundamentally altered atmospheric circulation. Climate models show that the Sahara acts as a giant heat engine, its intense summer warmth helping to shape the behavior of the jet stream, those powerful rivers of wind that steer weather systems across the globe. The creation of the desert may have influenced storm tracks over Europe and Asia, changing rainfall patterns continents away. Furthermore, the hot, dry air rising from the Sahara creates a layer of stable, dusty air that can suppress hurricane formation in the Atlantic, while its temperature contrasts can also energize other weather systems. A single, regional transformation sent ripples through the entire climate network. The collapse of the Green Sahara was not a local tragedy. It was a planetary reorganization, a stark lesson that a change in one part of the world can rewrite the rules of life and weather everywhere else. Hollywood would have you believe a single, miraculous oasis simply vanished beneath the dunes. The truth is far grander and more terrifying. The Green Sahara was not a singular paradise, but a continent-scale ecosystem, a sprawling mosaic of landscapes. Imagine not a dense jungle, but a vast, open savanna, much like the Serengeti of today, stretching as far as the eye could see. This was a world of seasonal grasslands, scattered acacia woodlands, and immense, interconnected wetlands. It was a world of variety, not a single mythical garden. The collapse, too, defies the simple storybook ending. There was no single cataclysmic day when the rain stopped forever. For the people living through it, the change was a slow-moving tragedy, a crisis that unfolded over centuries. A child might grow up hearing stories from their grandparents of a lake that was once a day's walk to the west, a lake they would never see themselves. The desertification was a creeping reality, a relentless tightening of the world's boundaries across multiple human lifetimes. This gradual yet unrelenting pace is precisely what makes it so relevant to our own time, where environmental changes often feel just as slow-moving and equally inescapable. Perhaps the most profound myth of all is that the Sahara is a permanent fixture. We see its vastness today and assume it is an eternal state, but the planetary clock is still ticking. The same orbital cycles that green the Sahara operate on a schedule of about 20,000 years. Right now, we are in a phase of weaker northern hemisphere summers, but in another 10,000 years or so, the tilt will shift again. The engine of the African monsoon could be reignited, pulling the life-giving rains back northward. The desert could bloom once more. This cyclical nature reveals a fundamental truth. The Sahara is not a wasteland. It is a climate state, one phase in our planet's endless rhythm of transformation. Understanding this reality, in all its complex, dynamic beauty, is the first step to grasping the true power of the forces that shape our world. And it forces a difficult question about our own era. If the planet's climate is capable of such dramatic, natural shifts, how can we possibly distinguish that ancient rhythm from the changes we are causing today? The Sahara's great transformation is not a singular anomaly in our planet's story. Across the globe, other landscapes have undergone equally dramatic shifts, each a powerful reminder of Earth's restless nature. Take the vast deserts of Central Asia. The sprawling Taklamakan and the immense Gobi were not always barren. Their creation is a tale of tectonic force and atmospheric change. As the Indian subcontinent collided with Asia, it thrust the Tibetan plateau high into the sky. This colossal wall of rock fundamentally altered air currents, blocking moisture from the Indian Ocean and redirecting the monsoon. The once green plains of Central Asia, caught in this new rain shadow, slowly starved for water, their fertile soils giving way to an ocean of sand and gravel. On the other side of the world, the Atacama Desert in South America holds the title of the driest place on Earth. Its extreme aridity is a masterclass in climatic convergence. The mighty Humboldt Current carries cold water from the Antarctic along the coast, chilling the air above it. Since cold air holds very little moisture, rain clouds struggle to form. To make matters worse, the towering Andes Mountains act as a second, impassable barrier, wringing the last traces of moisture from any easterly winds that manage to cross the Amazon basin. The Atacama is desolate not by one mechanism, but by a perfect storm of oceanic and geographic isolation. Even the mighty Amazon rainforest, that vibrant symbol of life, has known contraction. During past ice ages, when vast amounts of water were locked up in glaciers, global rainfall patterns shifted. the great jungle shrank back, fragmenting into isolated pockets of green known as refugia, surrounded by expanding savannas. The very forest that is now fertilized by Saharan dust has itself weathered periods of profound change, its boundaries breathing in and out with the planet's long climatic rhythms. These parallel stories from across the continents are more than just historical curiosities. They serve as a global laboratory for understanding climate dynamics. By comparing the Sahara's collapse with the birth of the Gobi or the steadfast dryness of the Atacama, scientists can identify the common forces that tip an ecosystem into a new state. Was it a change in orbit, a shift in ocean currents, a mountain range rising, or a combination of all three? Each desert tells a slightly different version of the same fundamental truth, that no landscape, no matter how immense or lush, is permanent. The Sahara's dramatic fall is just one vivid chapter in our planet's endless saga of reinvention, a saga whose next chapters are being written right now. That prehistoric warning from the Sahara echoes with terrifying clarity today. Our current experiment with the global climate is unfolding at a pace that makes those ancient orbital shifts seem almost languid. We are not applying a gentle, millennia-long pressure. We are delivering a sudden, violent shock to the system, and the very same feedback mechanisms that sealed the Sahara's fate are now being activated across the planet. Look at the Sahel, the fragile belt of land just south of the Sahara. Here, overgrazing and deforestation are stripping away the vegetative cover, exposing the light-colored soil beneath. This initiates the same albedo effect that crippled the monsoon thousands of years ago. A brighter surface reflects more heat, which weakens local rainfall patterns, which in turn kills more vegetation, exposing even more bright ground. It is the same vicious cycle, but this time it is turbocharged by human activity. The same pattern emerges in places like Central Australia, where the delicate balance between native scrub and the red earth is being disrupted. These are not isolated incidents. They are early warning signals, flickering dashboard lights telling us that systems we depend on are approaching their limits. The Sahara teaches us that these systems do not decline gracefully. They flip. Once a certain threshold of aridity or deforestation is crossed, the change becomes self-perpetuating and brutally rapid. The transformation from a carbon-absorbing rainforest to a carbon-emitting wasteland, for instance, is a regime shift with global consequences. This is why the preservation of our remaining great ecosystems, like the Amazon, is not merely an act of conservation. It is an act of global survival. The Amazon creates its own rainfall through transpiration, much like the Green Sahara once did. But as deforestation fragments this living pump, that critical moisture cycle is breaking down. Scientists are watching with dread for signs that the Amazon itself could be pushed past its own tipping point, triggering a collapse that would ripple through the world's climate. The story of the Sahara is a 5,000-year-old cautionary tale written in dust and pollen. It proves that climate tipping points are not theoretical. They are real, they are powerful, and once crossed, they create a new reality that can last for millennia. The question is no longer if such collapses can happen, but whether we will recognize the warning signs in time to prevent the next one. To test these theories, we turn to a digital time machine, the modern climate model. These are not simple animations, but vast mathematical universes running on some of the world's most powerful supercomputers. Scientists feed them the known conditions of 6,000 years ago, the precise wobble in Earth's orbit, the lower levels of greenhouse gases, the vast remnants of the northern ice sheets. Then they press play, setting the simulation in motion. The question is profound and simple. Can this virtual Earth, governed by the laws of physics, grow a green Sahara from scratch? When the model's screen displays a continent of lush savannas and sprawling megalakes, matching the paleoclimate data from dust and pollen, it is a moment of triumph. It means our understanding of the planetary levers, the orbital pacemaker, and the feedback loops is essentially correct. But these models are far more than a historical curiosity. They are the very same tools used to forecast the climate of the next century. By accurately retrodicting the past, we validate their power to predict the future. A model that can recreate the Sahara's collapse has earned its stripes, giving us greater confidence in its projections of rising seas, shifting rainfall patterns, and future tipping points. The digital ghost of a lost world becomes our most vital guide, a proven lens for seeing the consequences of our actions today. This reconstructed past is our best hope for navigating the uncertain future we are now creating. The same climate collapse that silenced the cave artists also emptied entire villages. Across the Sahara, the ruins of settlements tell a quieter but equally powerful story of disruption. These were not temporary camps but established communities, often strategically built on the very shores of those vast, now vanished lakes. For generations, life here was sustained by the water. Then the archaeological record shows a sudden break. The layers of occupation simply stop, the hearths grow cold, and the huts are left to the encroaching sand. This abandonment was not a choice but a necessity. The life support system for these villages, the freshwater lakes themselves, were disappearing before their eyes. The evidence of their final days is often found in the most humble of places, the ancient garbage heaps known as middens. These refuse piles are like a time capsule of daily life. In the lower, older layers, you find a bounty of bones from large fish, freshwater mussels, and hippos, a testament to a protein-rich diet drawn from a thriving aquatic world. But in the upper layers, that diversity vanishes. The bones are now from hardy, desert-adapted animals like hares and gazelles, and the shells are from small land snails. The menu had shrunk, reflecting a world that was itself shrinking around them. This dietary desperation is mirrored in the tools they left behind. The elegant bone harpoons and fishing hooks, perfectly designed for a life on the water, are abandoned. In their place, a new toolkit emerges. There are grinding stones for processing tough, wild grains and carefully crafted pottery vessels, not for cooking fish, but for the critical task of storing and transporting every precious drop of water. This was not a slow cultural evolution. It was a rapid, brutal pivot in technology driven by immediate survival needs. Each grinding stone, each water jar, is an artifact of adaptation, a direct response to a climate in freefall. These abandoned villages are the ground truth. They take the abstract data from ocean cores and cave minerals and translate it into a human experience. They show us a population not passively awaiting their fate, but actively struggling to reinvent their way of life in the face of an impossible drought. Their story is one of profound resilience, but it is also a narrative of ultimate failure. The climate shift was too vast, too rapid. Their resilience had limits, and in the end, the only option left was to leave, to become climate refugees in their own world. The silence of these ruins speaks volumes about what happens when an environment crosses a point of no return. Deep within the ice of Antarctica, a different kind of archive recorded the Sahara's death. Scientists drilling into the ancient glaciers pull up cores that are not just ice, but time capsules of the planet's past air. Trapped within that frozen water are millions of tiny bubbles, each one a pristine sample of the atmosphere from the time it was sealed away. By analyzing the gases in these bubbles, researchers can read a history of our planet's climate going back hundreds of thousands of years. It was here, in these Antarctic ice cores, that they found a strange and unexpected clue. Right around 5,500 years ago, as the Sahara was turning to dust, the global level of methane in the atmosphere took a sudden and significant dip. Methane is a powerful greenhouse gas, and its concentration is usually a reflection of the sum total of all its sources and sinks across the world. So what could cause the entire planet's methane blanket to thin at that precise moment? The leading suspect points directly to the dying wetlands of North Africa. Think of the Green Sahara not just as a savanna, but as a continent of enormous, shallow swamps. These waterlogged soils were the perfect home for methane-producing microbes, tiny organisms that thrive in oxygen-poor, soggy environments. As they broke down organic matter, they released vast quantities of methane into the air. The Green Sahara was, in effect, one of the planet's great natural gas fields, constantly leaking this potent heat-trapping gas into the sky. But as the monsoon rains failed and the megalakes evaporated, these wetlands shriveled. The microbial factories were shut down one by one. The land did not just dry up, it fell silent. The constant, low-level hum of methane seeping into the atmosphere from this vast region simply stopped. The loss was so immense that it registered globally, creating a detectable drop in the world's atmospheric methane levels. This is a staggering concept. A change in the swamps of one continent, even one as large as Africa, was enough to alter the fundamental chemistry of the entire planet's atmosphere. It demonstrates a level of interconnectedness that is both beautiful and terrifying. The collapse was not contained. It breached its regional boundaries and wrote its signature in the global air, a permanent mark in the Antarctic ice proving that no ecosystem, no matter how remote, truly stands alone. That dust, once a silent signal of collapse, has become an active geological force. We have seen how it records the desert's birth in deep-sea mud, but its journey does not end there. Each year, billions of tons of fine mineral dust are lifted from the Sahara's surface, embarking on a planetary voyage. This immense plume is far more than a passive cloud. It is a dynamic regulator with the power to cool continents and fertilize oceans. High in the atmosphere, these countless microscopic particles act like trillions of tiny mirrors, scattering a fraction of the sun's intense energy back into space. This creates a subtle but measurable global cooling effect, a sunshade woven from the very substance of the desert itself. Yet the dust's influence grows even more complex as it interacts with the building blocks of weather. Each particle can serve as a nucleus, a seed around which water vapor condenses to form clouds. This can potentially influence the timing, location, and even the type of precipitation that falls thousands of miles away, subtly altering the rainfall received by regions far beyond the desert's borders. But perhaps the most profound role of this traveling dust unfolds when it finally descends upon the ocean. The iron and phosphorus within it act as a potent fertilizer for phytoplankton. These microscopic, plant-like organisms are the foundation of the marine food web. When they bloom, they perform a remarkable feat, drawing vast quantities of carbon dioxide out of the atmosphere through photosynthesis. A portion of this carbon eventually sinks to the deep ocean floor, locked away for centuries. In this way, the dust from a dead world helps to cleanse the global atmosphere. This turns the entire narrative of the Sahara's collapse on its head. The desert is not merely a fossil, a static monument to a past climate disaster. It is a living, breathing entity that exhales dust across the planet, actively participating in the Earth's climate system to this very day. The planet created the desert, and the desert, in turn, began to shape the planet. The ground beneath our feet is far less solid than it appears. We tend to see our world as a finished product, a stable stage upon which human history unfolds. The story of the Sahara shatters that illusion completely. It reveals that the world map is not a permanent document, but a single frame pulled from a film that has been playing for billions of years. The continents themselves drift on a molten sea, and the climates that cloak them are in constant, slow-motion oscillation. What we identify as the defining feature of a region, its very identity, is merely a phase. A desert was once a savanna, and that savanna may one day be a forest again. This is a humbling realization. Our entire civilization, with all its cities and agriculture, has blossomed during an unusually quiet and stable chapter in Earth's long, turbulent history. We built our world during a climatic sweet spot, a fortunate interlude between ice ages and desert expansions. This deep time perspective is not just an academic exercise. It is a central context for the changes we are initiating today. When we alter the atmosphere, we are not tweaking a static system. We are applying immense force to a dynamic, sensitive, and ever-changing planet that has a history of dramatic flips. Recognizing the ephemeral nature of landscapes fosters a profound sense of planetary stewardship. It teaches us that the world we inherited is not the world we are destined to have, and that our actions now are writing the script for the landscapes of tomorrow. The celestial clock is still ticking, and its hands are moving toward another green phase for the Sahara. Based on the predictable rhythm of Earth's orbit, in roughly 10,000 years, the northern hemisphere will once again bask in more intense summer sunlight. This astronomical shift should, in theory, re-energize the African monsoon, pulling the life-giving rains northward to paint the dunes with savanna grasses and acacia trees once more. This natural cycle is as inevitable as the turning of the seasons, yet a new and unpredictable variable has been introduced into this ancient equation: humanity itself. Our massive experiment with the global climate through the emission of greenhouse gases now overlays this natural cycle, creating a future that is far from certain. Some climate models suggest that a warmer world could supercharge the monsoon, causing heavier rainfall that might accelerate the greening process. Other models, however, paint a starkly different picture. They indicate that the complex interplay of a warmer atmosphere with pollution from industrial aerosols could actually disrupt the monsoon's circulation, potentially delaying or even preventing the return of the rains. The natural destiny of the desert is now entangled with the consequences of our own actions. This uncertainty has sparked ambitious, almost science-fictional proposals to take control of the Sahara's fate directly. Vast geoengineering projects have been envisioned, covering millions of acres with solar farms to power massive desalination plants, or planting immense forests of drought-resistant trees to artificially lower the albedo and jumpstart the monsoon. These are not mere thought experiments, they are serious proposals with profound implications. What would happen to global weather patterns if we altered the reflectivity of an entire continent? How would such projects impact the unique and fragile desert ecosystems that have evolved over millennia? The ethical questions are as deep as the desert sands. Do we have the right to engineer a continent's climate, even with the best intentions? The future of the Sahara is no longer a story written solely by the slow dance of the planets. Its next great transformation will be a complex dialogue between celestial mechanics and human choice, a chapter we are now beginning to write. So we are left with a story of extraordinary convergence. The orbital pacemaker gave the first gentle push, a slow dimming of the northern sun over thousands of years. On its own, this might have led to a gradual drying. But Earth's own systems took that small signal and turned it into a roar. The albedo effect began to brighten the land, cooling the surface and crippling the monsoon engine. The dying vegetation broke the transpiration cycle, choking off the atmospheric moisture that seeded the next rain. And far out in the Atlantic, shifting currents pulled the rain belt itself hundreds of miles to the south, severing the final lifeline. These feedbacks did not just add together, they multiplied, creating a runaway train of environmental collapse. The system crossed a threshold, a tipping point, and the change became self-fueling and brutally swift. Within just a few centuries, a transformation that should have taken millennia was complete. The proof lies in the harmony of the evidence. The dust in the deep sea mud, the fossilized shores of megalakes, the silent testimony of pollen grains, and the abandoned tools in empty villages, they all sing the same tragic song in perfect unison. This was not a simple dry spell that the land could recover from. It was a fundamental regime shift, a violent and permanent reorganization of an entire continent's climate and life. Every piece of this ancient puzzle, from the ocean floor to the cave wall, locks into the next. The narrative is no longer a collection of scattered clues, but a single, undeniable epic of planetary change. The day the rainforest became a desert was not a single event you could have marked on a calendar. It was a pivotal era, a slow-motion cataclysm that reshaped a continent and fundamentally altered the global climate. By reconstructing this dramatic transformation, we gain far more than just historical knowledge. We acquire a deeper, more intuitive understanding of how our planet actually works. The Sahara's epic story teaches us about the terrifying power of feedback loops, where a small change can trigger an unstoppable cascade. It confirms the harsh reality of climate tipping points, those invisible thresholds which, once crossed, lock in a new and often hostile reality for millennia. Most of all, it reveals the profound interconnectedness of life, land, and atmosphere, showing how a shift in one region can rewrite the rules for the entire world. As we now face our own period of unprecedented environmental change, the lessons from this ancient cataclysm are not just relevant, they are essential. This is a stark reminder of the fragility of the complex systems that sustain our civilization. The same forces that turned a savannah to dust are active in our world today, amplified by human hands. This knowledge is not meant to paralyze us with fear, but to empower us with clarity. The past is speaking to us, offering a wisdom carved by time itself. Let this journey into Earth's dramatic history inspire in us a renewed commitment, a collective drive to understand, protect, and live in harmony with our dynamic and ever-changing world.